What's the biggest thing most people in social science get wrong about correlation?
That's an important question. They don't know what it means. There are SGD people who really think that experts have a problem, and there are good results there, and they ask the people to do the regression.
Mm-hmm.
What does it mean? And they can't explain their own results. They know the equation, they couldn't explain the graph, how much this represents of that. So there are a lot of incompetence in social science, and they use metrics they don't understand. Like a lot of people thought correlation was an objective thing. It's a measure that depends on subsample and then has a very limited meaning. And also, they don't realize that when you do visually, that correlation of 50 is not halfway between 0 and 1. It's much closer to 0.
You have this saying, so people are familiar with the phrase correlation isn't causation. You have this phrase correlation isn't correlation.
Yeah, exactly. I had a lot of Twitter fights with people, and that was fun because I didn't know that people didn't think of correlation that way. That's another thing. If you look in finance naively, you see that the effect of the mean of correlation, it appears to be say X and Y are correlated. Your expectation of delta X is going to be rho, sigma X over sigma Y, all right? Based on the time delta Y, all right? You're linking, you observe the effect of X based on observation of Y. But for betting and decision making, it's not that. It's more like a factor that's something like rho square or 1 minus rho square, or like similar to the minus log of 1 minus rho square. So in other words, very nonlinear. In other words, low correlations are noise, and again, 50 is not halfway between 0 and 1.
Right.
And 1 is infinity. That's for decision making. And you put that into your either Kelly criterion or any form of decision making, and then you realize how much more I should bet on X knowing Y, or on something knowing some side information, and simplified. When I made a graph showing how it has this, how visually you can see it. You see, you can mutual information, which is an entropy measure, is vastly more informative. That's in a linear world. And now as you go nonlinear, visibly, if you have a V curve, zero correlation and infinite mutual information. So there's that mistake with correlation, but there are other mistakes in correlation not well explored. I didn't go into it because I'm into cycling. I'm too lazy to go into it, but I showed that basically it's not it's not, it's sub-additive. Okay,
Right.
to give you an example, if I take a correlation of a row, it's not going to be a row in the positive. If you sum up the quadrants, positive, X positive, Y positive, X negative, if you sum up the quadrants, you don't get row, because visibly the mean shifts according to every quadrant. So it's going to be sub-additive in absolute terms, which is a problem. It tells you that subsampling, taking a correlation of subsample, doesn't give you a correlation of the whole. And that's not well known. And I wrote a paper. I don't feel like publishing it because the problem with referees is it's hard to get good referees. So on the last paper, we had a guy says telling me, I'm substituting correlation with mutual information, and say, do you have evidence that correlation is a metric? You don't say you have evidence, scientific evidence that correlation works. It is a metric, right? By definition. So you can use it for evidence. So I said, okay, you got to give up on publishing too much because of contact with referees who are not sophisticated unless you find the journals that have the good referees. So maybe I'll publish these results because the practical implication is monstrous.
Mm.
And maybe I'll put it here. I'm the second edition, third edition. I add correlation. Smart people get it. Smart people, but you have to know math to know that correlation is not what it means.
Right.
And then your regression, they do regression was an R square of 0.05.
And they think, anything above 0.5 is kind of celebrated in social science.
I see, but the problem is if you include model error, okay, it dilutes the 0.5 big time.
Right. It's crazy. I mean, there's just so much of social science is built on correlation.
And is so huge crowd. Plus the other thing is how to translate a result. Let's say that you see papers and you see a huge cloud. Okay, and it tells you, oh, look, IQ and education, or IQ and wealth. All right, okay, very good. Or IQ and income. First of all, it's wrong. Income is fat-tailed. IQ is by design thin-tailed.
So you can't regress them.
Yeah, but let's say we did that. They got a big noise. In other words, if you hire someone based on IQ, it's such a, you get such a low probability in your favor for a sample of one. You need a lot of large numbers. They don't get it.
Mm-hmm.
So, you should hire on. No, because with such a weak correlation, the law of large numbers, okay, doesn't start acting till you hire, I don't know, a whole town or something. You see, you get the idea. So you're getting noise,
right?
So that metric is noise unless you have a wholesale, because of visual variations, So the way the law of large number works, I explore it here, even for thin tails, all right, it's misunderstood. What I call the reverse law of large numbers. If you take a property, say how much hypertension is going to be lowered by this medication, all right, and reverse it and look at what are the odds of working on your patient, you get a complete different answer from the one they think. Because on average it works, say 4 points, but some people it's going to be a lot higher and so forth. So this is where the interpretation of the statistical claims that they're making, it can be messed up.
Right.
I mean, I saw it in the IQ. First of all, they don't know how to compute a lot of things, and they don't know how to read correlation, but also how they interpret it. We're going to tell them, okay, put a graph with a noise. And you see a graph and you realize, at the best of their claims, in these papers that show the effectiveness of using IQ, even, with a circularity, in fact, that if you're good at taking exams, you're going to have a high IQ, but you're also going to get a good college degree. And that helps your income in the beginning, right? We're not talking about wealth or stuff, so it's for employees. So even taking all of these, you look at the cloud and say, well, you know what? You can't use it for any individual hire. You see? You need a batch.
Mm-hmm.
And then there are a lot of other things in IQ that tells me that either these people, I used to think that they're mean, like, in other words, like a lot of race science comes from people being, having some kind of problem, all right, sociopathic problem. So I thought that, but I think no, they're just plain dumb. And then and you can see it in the real world. Think about it. If these people know anything, they'd go make money and then go continue doing psychology, but they can't.
It's very true.